Hi everyone, welcome back to Whiteboard Math. The subject of today is Cofactor Expansion. This video requires you to know how to find determinants of order 2 and order 3. Luckily for you, I've made videos on those topics before, which are linked in the description. If you need to revise your knowledge, you can find them there. Let's no longer waste any time and get straight into this. On your screen you can see matrix A with entries 1, 0, 2, 1, 2, 1, 4, 3, 2, 0, 1, 3 and 1, 0, 1, 1. Now we want to find the determinant of A using cofactor expansion. We can choose any row or any column to do this. If we have a closer look at the matrix on your screen, we can see that column 2 consists of 3 zeros. We will choose this column because it will make things easier later on. We start by finding the cofactor of the 0 in the first row and the second column. To find this cofactor, we multiply 0 by negative 1 raised to the power 1 plus 2, because the element is in row 1 and column 2. We then multiply this by the determinant of order 3 that remains when we remove the first row and the second column of the determinant of A. So the determinant with entries 2, 4, 3, 2, 1, 3 and 1, 1, 1. After that we add the cofactor of the 1 in the second row and the second column. To find this cofactor we multiply 1 by negative 1 raised to the power 2 plus 2, because the element is in row 2 and in column 2. We then multiply this by the determinant of order 3 that remains when we remove the second row and the second column of the determinant of A. So the determinant with entries 1, 2, 1, 2, 1, 3 and 1, 1, 1. Next up we add the cofactor of 0 in the third row and the second column. To find this cofactor we multiply 0 by negative 1 raised to the power 3 plus 2. Because the element is in row 3 and column 2. We then multiply this by the determinant of order 3 that remains when we remove the third row and the second column of the determinant of A. So the determinant with entries 1, 2, 1, 2, 4, 3 and 1, 1, 1. Lastly, we add the cofactor of 0 in the fourth row and the second column. To find this cofactor we multiply 0 by negative 1 raised to the power 4 plus 2, because the element is in row 4 and column 2. We then multiply this by the determinant of order 3 that remains when we remove the fourth row and the second column of the determinant of A. So the determinant with entries 1, 2, 1, 2, 4, 3 and 2, 1, 3. Now you can see why we chose the second column containing the 3 zeros. Because the first, third and fourth part of this calculation are all multiplied by 0, they are all equal to 0. For this reason we only have to calculate the second part of this calculation. I would advise you to always use the row or column with the most zeros when you use cofactor expansion, as this will save you a lot of time. Let's now find the answer. 1 times negative 1 to the power of 4 equals 1, meaning that you only have to calculate the determinant of 3 with entries 1, 2, 1, 2, 1, 3 and 1, 1, 1. You can see how we solve this on your screen. We use the rules for determinants of order 3 that we also used in our previous video. We end up with the final answer of 1. This means that we have found the determinant of A by using cofactor expansion. If you want to, you can pause the video so you can calculate this determinant yourself. That brings us to the end of the video. If it was helpful, please help me out by liking this video and subscribing to my channel. It is much appreciated, as it took me a lot of time to make this video. See you in my next video.